Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. My name is Muhammad SHAFI bin ABDULLAH and my supervisor is Professor Madya Dr. Muhammad Hafiz Fazli bin Muhammad Fawadi. My presentation today is titled as IoT-based training system for engineering lab activity. Without wasting much time, I will start with the agenda for this presentation, starting with the introduction, then literature review, followed by methodology, and end with summary of PSM 1. Introduction. As we know, engineer has the most hands-on and experimental job in the world, while engineering laboratory is one of the subjects that is taken by engineering students all around the globe. Engineering students train their skills through lab activity, but nowadays technology has evolved very fast. One of the evolution are about the Internet of Things, IoT. So this approach has to be utilized in our daily life, and in my context, this approach will be utilized on engineering lab activity. Problem statement are as follows. The first one is conducting engineering lab activities using traditional way seems to be less productive. The second one, a lot of students find it difficult to monitor the engineering lab activity due to the space and number of participants when doing the lab. And the third one is lecturer found it difficult to track the result and data collected by students. To answer the problem stated, here are the objectives for this project. First, to identify the development of Internet of Things usage for engineering lab activities. Second, to propose a training system that can directly activate the engineering lab activities by using an application. And the last one is to evaluate the effectiveness of the system, including collection of data from the application for the engineering lab activities. Next is the scope. First, the product will help the usage for engineering lab machine limited by using the gadget that can download the application. Second, the usage of the product is focused on student and lecturer that involved in engineering lab course. Third, this project focused on the design and fabrication of the structure and mechanical component only. And the last one is the data collection from the application are limited to certain data only. For example, the graph from the activity and the result of each activity. Coming to the next agenda, which is a literature review. This slide is a review about Internet of Things. According to Qinwei, Sheng and others in 2016, they describe about IoT definition. Next, according to Zhang Qi, Li and others in 2017, they describe the basic component included in IoT system. According to Blanco J. Garcia and De La Morenas in 2018, they describe the development of IoT. Next review will be about engineering lab. According to Albe and Isma in 2021, they describe about traditional approach for engineering lab. According to Davenport, J.L. Rafferty and Yaron in 2018, they describe about virtual lab. According to Junction in 2018, he described about remote lab. Next is about mobile application approach. According to Jiang and Vesin in 2016, they describe about native apps benefit. According to Iglesias and Misandil in 2015, they describe about the mobile website. According to Al-Dayal and Al-Nafjan 2017, they describe about the growth of smartphone industry. The last review is about hardware of IoT. According to Baragan in 2016, he described about connecting an Arduino board. According to Upton in 2020, he described about Raspberry Pi microcontroller. According to Richardson in 2014, he describes about BeagleBone microcontroller. Methodology. This is the flowchart diagram for this project process. It will start by mobile apps with the help of Blink software. Blink is a software to develop an application, followed by getting an IP address. Then it will establish connection with the help of microcontrollers such as Arduino Uno and ESP8266 Wi-Fi module. If the connection is unsuccessful, it will start the process. If successful, all the parameters has to be initiated according to the experiment which will be run after that. From the experiment, the result will be generated on Blink apps. Then we can decide whether to run the experiment again or just end the process. After that, in this project, the system will use a change waterfall that provides the developer with the option of going back to the previous or starting step. This model is an enhancement of the traditional model of waterfalls, the ordered process sequence with the sum of flexible iterative steps to allow document and design review to guarantee the performance of the customized software, its reliability, and its maintenance. This proposed method is stopped at the testing stage, as this project is only generating a prototype. Start with requirement analysis. The process will be started with defining project area and title, followed by literature review, analysis of problem statement, project scheduling, and identifying scopes, objectives, significances. These are the table for the activities and the outcome of the activities. The second step of the waterfall model is the design of the program and framework. The framework is designed to meet the requirement of the process. In the course of the design phase, much trouble will result without a thorough understanding of the requirement for this system. All these processes are dependable, which develop as a waterfall flows slowly through the phases. The next phase will not take place until the last stage is thoroughly analyzed. The next step is the implementation. This project will be implemented on two different engineering lab activities. The first one is pressure vessel. The purpose of this lab is to examine the stress and strain on a closed-ended cylinder are impacted by various internal pressure. Figures show the setup of the experiment. The other one is tension test. The purpose of this lab is to gain an understanding of the relationship between stress and strain and the difference between brittle and ductile materials, deformation of a specimen subjected to tensile load, and determining elastic material constants. Figures show the setup for tension test experiment. The last one is testing. To answer the third objective, which is evaluating the system effectiveness, according to this flowchart, functionality tests are carried out to ensure the correct functioning of all device components without any defect. The usability check if the device meet all criteria. All information concerning system development and results are documented in the final report. From this presentation, I can summarize that literature review findings enhance our understanding. Methodology helps shorten the learning curve as it is used in these projects. Then we can expect the development of this system will ease the engineering lab activity in future, and also the experiment chosen to implement this system is capable to cooperate with IoT approach. For next semester, discussion on the result and conclusion will be made. The biggest challenge for the upcoming works will be programming this system. For this, I will be learning about the programming from different platforms and also the help of my supervisor. That's all from me. Thank you.